This is Honors Geometry, Angle of Elevation and Depression. So we're going to use what we learned and we're just going to turn it into word problems. So the first thing I want to talk about is something called angle of elevation. So if you look up at an object, the angle your line of sight makes with the horizon. So if you look straight out, of course you're at 0 degrees. If you look up, that line of sight is now called the angle of elevation. But if you look down at an object, if you're looking straight out again, that's going to be 0 degrees. But when you look down, the angle your line of sight makes with the horizon is called the angle of depression. And I like this little picture here. I think it's a good representation. So this lady's up on top of the cliff. And if she looks straight out, of course, that's 0 degrees. But if she looks down, that's called her angle of depression. And the man's on the beach, and his angle of elevation, it's at his eye level again. It's not at his feet. It's at his eye level. And when he's looking up, that's his angle of elevation. And if you can see, the horizon is going to be two parallel lines. And then if you think of this line here as their transversal, you can probably guess what we're going to say about the angle of elevation compared to the angle of depression. They're alternate interior angles. So she should be looking down at the same angle that he's looking up. So angle of elevation, angle of depression, in this case, they're going to be congruent angles. All right, here it goes. You are skiing on a mountain with an altitude of 1,200 meters. The angle of depression is 21 degrees. Okay, so you're up. They seem like they're switching between feet and meters. We'll just assume it's one. We're going to say 1,200 feet. Okay, and he's looking down at 21 degrees. And remember, you can carry that 21 down here. And the question is, about how far do you ski down the mountain. So we're looking for the altitude in this case. So we're going to use our trig. So from the 21 degrees, this is our opposite. We're looking for the hypotenuse, OH, if we go back to our SOHCAHTOA. OH tells us we're going to use sine. So we say sine of a 21 degree angle. We put opposite on the top, which is that 1,200. And then our hypotenuse, which is our unknown. We're going to cross multiply. We're going to divide. So I grab my calculator, I punch in 1,200 divided by sine of 21. And it looks like he is going to have about 3,348.5 feet or meters. Let's look at an angle of another one. You want to build a skateboard ramp with a length that's 14 feet. So your ramp is going to be 14 feet long. You want to have an angle of elevation, so that's going up, of 26 degrees. Find the height and the length of the ramp. Okay, so let's do one at a time. This will be our opposite. This is our hypotenuse. So if we look at our SOHCAHTOA, opposite hypotenuse tells us we're going to use sine. Sine of 26 degrees equals opposite over hypotenuse. We're going to cross multiply. So I'm going to punch in my calculator, sine of 26 times 14. And it looks like the height of our ramp is going to be about 6.1 feet. At this point, if you wanted to, you could just do Pythagorean theorem and get your missing leg here. I'm just going to go ahead and use trig. So from the 26, this is our adjacent. I'm going to go ahead and still use that hypotenuse. So AH tells us this time we're going to use cosine. So I'm going to say cosine of 26 degrees equals adjacent over hypotenuse. I'm going to cross multiply again. So I'm punching in my calculator, cosine of 26 times 14. And it looks like the length of our ramp is going to be about 12.6 feet. All right. Now I wanted to show you a couple where you go backwards, use the inverse trig. So the hard part of the word problems is just sketching it. Once you have it sketched, it's just solving a problem, and we're pretty comfortable with that. It tells you a 100-foot building, so here's my 100 feet. Casts a 300-foot shadow. I think my drawing's off a little bit, but that's okay. The question is, what's the sun's angle of depression? So again, if we were standing on the top of that roof, our angle of depression would be right here. And we know we're allowed to carry that over because they're alternate interior angles. So we're going to use this angle. So from this angle, this is opposite, this is adjacent. So that tells us we use tangent. And I'm looking for an angle, so that's when I use my inverse tangent. And it's opposite, which is 100, over adjacent, which is 300. You can simplify that if you want. So I'm going to press second tangent, 1 divided by 3, or 100 divided by 300, and it tells me the angle of elevation is about 18.4. My drawing's not very good. That's obviously not 18.4 degrees. Okay, one more. An escalator is 110 feet long. There's our escalator. And it rises 32 feet up to the next level. So the question is, what's the angle of elevation? So that's going to be right here that we're looking for. So this is our opposite, and this is our hypotenuse. Opposite hypotenuse tells us we're using sine. We're going backwards because we're looking for the angle, so I want my inverse sine. Opposite over hypotenuse. So I'm going to go to my calculator, press second sine to get my inverse sine, 32 divided by 100. And it tells me my angle of elevation. Oh, how about that again? I'm getting about 18.7 degrees. Okay, go ahead and try the word problems. I threw a couple special right triangles, some regular Pythagorean theorem in there, but we've covered everything you need to know. They're just in word form. Let me know if you have any questions. Thank you.